Good afternoon, everyone. Am I audible to you?
Yes,
Good
ma'am.
afternoon, ma'am.
Yes, ma'am.
Good afternoon.
Yeah, yeah.
Good afternoon, ma'am.
Okay. Yeah. So,
Afternoon, ma'am.
yeah, I'll be sharing the screen. Let me know if it is visible, okay? So, question paper I'm sharing. Yes, is it visible?
Yes, ma'am.
Yes, ma'am.
Yeah, fine. Now both the screens are visible, right?
Yes, ma'am.
Yeah. Okay, we'll start solving this. We are solving the level 2 problems of some basic concepts in chemistry. Okay. Yes.
Ma'am,
Yeah. Tell me.
sending the solutions in the WhatsApp or should we copy it down?
I will send you. The same
Okay.
copy I'll be sending it to you. Okay.
Okay.
Yeah. Fine. So the first question says if density of the solution is 3.12 gram per ml, right? So the density of solution is 3.12 gram per ml. The mass of 1.5 ml solution in significant figures is, right? So from this, we get to know that 3.12 gram is the mass of 1 ml. Per ml meaning it is 1 ml. Is that correct? So 3.12 gram is the weight of 1 ml. Therefore, what is the weight of 1.5 ml? That's the question, right? So I'm going to take that 1.5 as 3 by 2. So 3 by 2 into 3.12 divided by 1, right? So 3.2 is in grams. This is, and 1.5 is nothing but 1.5 is nothing but, okay, 1.5 is nothing but ml. So this is ml and divided by 1 I have done. So which is also in ml. So ml gets cancelled. The answer what you have is in grams, right? So what we have here is 2 1 is 2, 2 is remaining. So you have 21, which is, sorry, 1 is remaining. 5 is 10, again 1 is remaining, 6. So 3.3 into 1.56, the value would be, yes, can you tell what the answer you're going to get? Solve it and tell me the answer.
4.680.
Yes, 4.68. But they have asked you to keep it in significant figures, right? So how do
4.7.
you, yeah, it is 4.7. That's the right
4.7.
answer. Yeah, 4.7 grams is the right answer. This is first one. Coming to the second one, a sample of calcium carbonate, CaCO3, has the following percentage composition. Calcium is 40%, carbon is 12%, oxygen is 48%. If the law of constant proportions is true, the law of constant proportion is true, meaning irrespective of the source, the ratio of the masses remains constant, right? So that is holding good in this question. Then the weight of calcium in 4 gram of a sample of calcium carbonate. So we know that in 100 grams of CaCO3, how much calcium do we have? 40% is nothing but 40 grams
40
of
grams.
calcium present in 100 grams of calcium carbonate. So in 4 grams of calcium carbonate, we have to tell what is the mass of calcium. So therefore, 4 gram of calcium carbonate contains how much? Yes. What's the answer?
1.6 grams.
Yes, that's the right answer. Right. So this is 8 divided by 5, which is 1.6 grams. Right. This is the
Option.
second one. Yeah, it is option C. So I write the options also. Option C, 1.6 gram. First one is option A. So A is 4.7 grams. So how did we get this as 4.7 grams? Because of the two values, right? 1.5 we have and 3.12 we have. The minimum number of significant figures is present in 1.5. Therefore, our answer should have two significant figures, the answer being 4.7. Third one, 1 gram of an oxide of A contained 0.5 gram of A, right? So we have an oxide which is 1 gram. 1 gram oxide has 0.5 grams A and 4 gram of another oxide. So this is oxide 1 and this is oxide 2. So can you tell which law should hold good if we are taking two different oxides?
Multiple proportion.
That's it, right? So you can directly see conservation of energy is not here. So constant proportion doesn't hold good if we are taking two different oxides. Say for example, CO and CO2, SO2 and SO3. If we are taking two different, yeah. So therefore, the multiple proportions holds good. Okay, now we got to know that multiple proportions is holding good. Can you tell what could be the ratio of the one element with respect to the other oxide? Can you tell the ratio of that? So if the question is asked this way, so if the question is satisfying the multiple proportions, what is the ratio of A in both the compounds? If they ask, what would be the answer? Can you answer that one?
5:4.
Is it? No? Check it properly. See here, 1 gram has 0.5 gram of A and the other oxide is 4 gram contains 1.6 gram of A. Correct. So if this is A, what would be the oxygen present? So in 1 gram, 0.5 gram of oxygen is present. In this, of the 4 grams, 1.6 is A, therefore 2.4 grams would be oxygen. Correct. So we have to fix the mass of 1. So if I want the ratio of A in oxide 1 is to ratio of A in oxide 2, what do I do is fix the mass of oxygen. Is that correct? Is it correct? I have to fix the mass of oxygen. Yeah, to tell the ratio of A in oxide 1 and oxide 2. So how do we fix this mass? Can you tell how do we fix the mass?
Multiplication
Yes.
on any one of the side.
Pardon?
Multiplication on any one of the side.
Yeah, or you can take one for oxygen in both the oxides. So what I do is divided by 0.5 divided by 0.5. So what do I get is 1 gram and 1 gram, correct? In this, I divided by 2.4 and here I divided by 2.4. So this becomes 1 and what does this become? So 4 4 is 16 and 4 6 4 by 6, 2 by 3, correct? So in first one, A is 1 and in the second one you have 2 by 3. The ratio is 3:2. Fine.
Okay.
This can also be asked. This is not asked actually, but this could be actually asked. That's a very simple one. So by knowing it is two different oxides of A, so it can be AO2 or AO3 or it can be AO2 or A2O3, whatever it can be, right? So for that, we are finding the ratio according to the multiple proportions. Therefore, we are getting the ratio as 3.2. This is actually not asked. It is satisfying the law of multiple proportions. See, somebody has not muted your mic. Please mute your mic. It is option D, satisfying the multiple proportions. Okay. If I want the ratio of A in both the oxides, it is 3:2. Right. Yes. Coming to the question number 4. Is that fine? Are you getting it? Hello. Who is that? Whose mic is not muted? Please mute your mics. Yes. So this is the third one. If the ratio is asked, you have to do it this way. Okay. Fourth one. The composition of compound A is 40% X and 60% Y, right? So A has 40% X and 60% Y. The composition of compound B is, so B composition is 25% X and 75% Y, right? According to the law of multiple proportions, the ratio of the weight of element Y in compounds Y and B is. So what we have to find is the ratio of Y in A to the ratio of Y in B. Is it correct? This is the question, right? Again, the same way we have to do this one. So how do you do this one? What we did in the previous one, the same thing we are going to do. What can we fix here? Fix the mass of X so that Y will be varying, right? So according to the law of multiple proportions, we have to check the ratio of weights of one element with the fixed mass of the other element. So here we are going to fix the mass of X. So how do we do it? Anybody? Like the previous one, how do we do? Divide it by 40 and divide this also by 40. Divide this by 25. Divide this also by 25, right? So this comes out to be 1 and this is coming out to be 3 by 2. This is 1 and this is coming out to be 3. So you have 2 by 3 is 2. 3. Correct. Sorry, 3 by 2 is 2. 3. So 3 gets cancelled. Your ratio is 1:2. Are you getting it?
Yes, ma'am.
Yes. So fifth one, given that the abundances of isotopes, so abundances are given. Fe54 isotope is 5%. What happened? Yes. Fe56 is given to be 90% and Fe57 is given to be 5%. Right. The atomic mass of Fe, that's the question. Right. So we have to find atomic mass of Fe, which is nothing but the average atomic mass. Is that correct? When you have the different isotopes and different abundances, we have to find the average atomic mass of Fe. So average atomic mass, we are going to do it by the summation of the atomic mass into the relative abundance. So I'm directly writing atomic mass is 54 into the relative abundance is 5%. I directly take 5 plus whole divided by 100 I'm going to write because 100 remains the constant
ಅಮ್ಮ
in all the
ಮಿಕ್ಸಿ
three.
ಹೊಡೆದೋಗೈತಾ ನೋಡಮ್ಮ. ಇಲ್ಲ
56.
ಅದು ಜಾರ್ ಹೊಡೆದೋಗಿರ್ತಿತ್ ನೋಡು, ಆ ರೇಂಜಿಗೆ ಬಿದ್ದೈತಂದ್ರೆ ಕೆಳಗೆ ನೋಡೋದು.
Somebody has not muted your mic. Can you please mute it? 57 into 5, right? So this is whole divided by 100. So what we are going to get is 50. See, I'm going to split this 54 as 50 into 5 plus 4 into 5, right? 55 is 250 and 4 5 is 20. So this comes out to be 270, right? Again, 50 into 90 plus 6 into 90. So what is 5 into 9 is 45. So 4500 plus 9 6 is 54 540. So this comes out to be 0 4 0 and 5, right? Plus 50 5 is 250 and 7 5 is 35. So what we are going to get here is 582 all divided by 100, right? So what we are going to get is 270. We can do it as such. So 5005
5595.
and yeah, 5595 divided by 100. So you're going to get 55.95. Good. That's the right answer, right? So average atomic mass would be in AMU or it should be in U, but they have not.
இதுல
Yes, they have
வேண்டாம்,
not
share
given
கரோ
anything.
பண்ணு.
So it is 55.95 is the answer. So answer B.
இப்ப நானும் டவுன்லோட் பண்ணுமா அந்த ஆப்?
So B 55.95. Yeah, this answer was, fourth one was 1:2, which was A. A 1:2. This is fifth one. Coming to the sixth one. If the percentage of selenium in peroxide anhydrase enzyme is 0.5% by mass. So selenium is 0.5% by mass. Okay. Atomic mass of selenium is given, which is 78.4. Atomic mass of selenium is 78.4. Then the minimum molecular mass of the enzyme is, right? So the minimum molecular mass
Install வச்சாது.
we have to find. Correct. So I know that 0.5% by mass meaning is 0.5 grams in 100 grams of the enzyme. Correct? So obviously minimum molar mass meaning minimum 1 selenium should be there. Correct. So minimum 1 selenium mass is 78.4 grams
Install
is present in what mass? If you find that, you get to know the minimum molar mass of this enzyme. Correct. So can we tell what it is? Can you calculate? I have given you the clue.
78.4 by x into 100 is equals to 0.5%.
0.5%.
Yes,
No,
ma'am.
no, no.
Then the equation we'll get the answer.
Yeah, what's the answer? Calculate that and tell. So
1.5
minimum is
to 8 into 10 power 4.
Yes, ma'am.
yes. Are you getting the answer?
1.56 into
6,
10 to
8
the power
into 10
4.
power 4. Yeah,
Yes,
right
ma'am.
answer. Okay. So what you're going to get here is 0.5 gram is present in 100 gram. Therefore, 78.4 gram is present in what mass of the enzyme gives you the minimum molar mass. So X would be here 78.4 into 100 divided by 0.5. 0.5 is nothing but, what can we write 0.5 as in fractions?
5 by 10.
Yes. So I write here 5 and 10. I'm writing it here. Right. So this is 5 ones are, we are multiplying it with 1000 is nothing but 10 power 3. So 5 ones are 5 ones are 5. 2 is remaining. Again 5s are is 25. So 3 is remaining. Point I'm going to put.
எல்லாமே அதுல ஸ்னாப் அது எல்லாமே இது அதுல என்னது போட்டோஸ் நோட்ஸ் போட்டோஸ்லாம் இருக்கும் அதெல்லாம் எல்லாமே எனக்கு நான் delete பண்ணிக்கிறேன். நம்ம நோட்ஸ் எல்லாம் இருக்கும் அதெல்லாம் சென்ட் பண்ணு.
So if I shift the point 1.56 into
வேணும்னா
10.3. Yeah, good. You have done it, right? So this is the mass. Hello. Hello. Somebody has. See, please mute all of your mics. See, minimum molar mass they have asked. Minimum meaning at least 1 selenium should be present in that, right? So I have taken the mass of that atom, that is the atomic mass, 78.4 grams, right? So that's the right answer. Next, seventh one, answer is your A. So A option. Seventh one. If certain compound has the molecular formula X4O10, the formula is O6. If 10 gram of compound contains 6.06 gram of X, the atomic mass of X is, right? So 10 gram of the compound, 10 gram of compound is X4O6. So 10 gram of the compound contains 6.06 gram of X. The atomic mass of X, that's what they're asking. Right. So can I tell 10 grams contains 6.06. Therefore, 100 grams of the compound contains how much? Into 10, which is 60.6 grams of X. So, can I tell 60.6 gram of X present in 100 grams of X4O6 as 60.6% of X? Can I tell like that?
Yes, ma'am.
Yeah. So, this is 60.6% X. So I know that what did I write for selenium? In selenium, I wrote for 0.5% as 0.5 grams in 100 grams. Correct. Similarly, so 60.6 grams in 100 grams of the compound is 60.6%. Correct. So now I have to find the atomic mass of X. Right. So how do you find? Can you? I have already given you the clue. Can you guess what should be done keeping the percentage? You can do it in two ways. See, I will write both the ways. First way and the second way. If X is 60.6%, what is oxygen? What is oxygen?
39.2.
Yes,
39.4.
39.4%. Correct.
39.4.
Oxygen would be 39.4%. Now, what we can do is keeping the percentage of X and keeping the percentage of oxygen, we can easily find the atomic mass of X. So, in oxygen, I do this way. Oxygen percent from keeping oxygen, I'm doing this way. So, I know that 6 into 16 is nothing but the mass of oxygen divided by total masses. What is 16 into 6? 96.
90.
Into 4x would be equal to what is the percentage? 39.4%, which is nothing but 39.4 divided by 100. Fine. One method is this. You can do like this, or you have one more method, keeping x. So in this method, what you can do is, so how to take percentage of x? 4 into x atomic mass divided by 4 into x plus 96. Is that correct? So which is equal to 60.6%. That is 60.6 divided by 100. Can you solve any one of this and tell the answer? The clue is given for the question. You have to just find the x. X is nothing but the atomic mass of the atom X. Solve and tell me the answer. I'll do it. You just do and tell me the answer if you do it soon. Anybody? Yes. Solve and tell me the answer. Which becomes easier that you can solve.
X equals 45.76.
No, it's not right. It's not the answer.
Thirty-six point 91.
Yes, good.
37.
Yes, exactly. You're getting it right. So this is 240 plus 4, 244x plus 96 into 6 is 6, 6 are 36, 9, 6 are 54, 57 into 0 and 96. 6 and 5, 8, 5. Right, 400x. So 400 minus 244 would be
Ma'am, 37 AMU.
yeah,
Ma'am,
correct. That's the right
37, ma'am.
answer. Yes, right. That's the right answer. Correct. Yeah, right answer. 156x is equal to 5856. So x is equal to 5856 divided by 156. So what you're going to get is, if I take it as this, 3s is 450 and 6 yeah, you get it, approximately 37, correct? Yeah, right
Yes,
answer.
ma'am.
Which method you took?
First
First one or
one, ma'am.
second one? First one, yes.
First
So
one, ma'am.
yeah, by first method also you're going to get, by second method also you're going to get, right? So any method you can use, find x, you get the answer, right? Yeah.
By
I have
using
also
mass
done the first.
percentage, you did, no, ma'am.
Yeah, correct. Using the mass percent. Mass percentage of x is nothing but 60.6. Right. Of x, the percentage is 60.6. So formula for this is mass of x divided by mass of x4O6 is equal to the percentage of x. Is that correct? This is the formula. Understood?
Yes,
Ma'am.
ma'am.
Yeah. Keeping that, we have done this. Yeah. Next one, answer is option B. Yeah. Next one, eighth one. Yeah. 400
Ma'am, is
mg.
it 8.2?
You got the answer? Yeah, that's the right answer. So I'll do it. 400 mg of a capsule contains 100 mg of ferrous fumarate, right? So 400 mg capsule contains 100 mg ferrous fumarate. What is ferrous fumarate? See, you know, sodium acetate. How is sodium acetate obtained? You take acetic acid, correct? Remove the H, substitute sodium, you're going to get sodium acetate. Is that correct? Similarly,
NaOH
what we are
plus
going to do is
H3COH.
fumaric acid we are going to take. From fumaric acid, you are going to remove the hydrogens and substitute the Fe there. So you're going to get ferrous fumarate. Ferrous is nothing but Fe2 plus, ferric is Fe3 plus. So fumaric acid is CH double bond CH, COOH, COOH. This is fumaric acid, okay? I remove H from this becomes minus. I remove one more minus here. So to satisfy this, I'm going to put Fe2 plus. Is that correct? This is called ferrous fumarate. In ferrous fumarate, how many Fe do you have? Only one Fe. Is that correct? See, in the capsule, you have 100 mg of ferrous fumarate. I write like this. I know that one Fe is present in ferrous fumarate. Is it correct? I have to find how much of Fe is present in 100 mg, right? So have they given the fumarate mass? Yes. So 170 gram is the molar mass of ferrous fumarate. 170 gram of ferrous fumarate contains how many Fe? Only one Fe. What is the mass of one Fe? 56 grams, correct? So 170 grams of ferrous fumarate contains 56 grams of Fe. Therefore, 100 mg of ferrous fumarate contains how many mg of Fe is the answer, right? So 100 mg into 56 grams over 170 grams, right? You get the answer in mg because grams gets cancelled. So what would be the answer? I want this answer. Can you tell the answer for this one?
2 point.
Oh, I'm missing the questions. This is eighth one, right? Yeah, eighth one. So what do we get here is 1010 gets cancelled. So 10 ones are and
32.9.
yes, 32.9 mg you're getting, right? They're asking they're asking you what is the percentage of Fe in the capsule, not in the fumarate, right? So what we are going to do is mass of Fe divided by mass of capsule into 100. If we do, we are going to get the percentage. What is the mass of Fe? 32.9 divided by what is the mass of capsule, which is 400 into 100. So 100 gets cancelled. 4 ones are 4 eights are is 32 and point 2s is 8. 1 is remaining.
8.2.
Point we have taken. So 2s is again 8. 8.22. We have the answer as 8.2. So answer is option A, which is 8. Right? So you're getting it right?
Yes, ma'am.
Yes. So next, ninth one. The crystalline salt Na2SO4. See, you have to do this. I've already given you the clue for how to do the problems based on the percentage, right? Here the percentage is given. So the compound is Na2SO4 dot XH2O. On heating it, right, what mass is lost is 55.9% of the mass is lost. Meaning, what would be lost is water would be lost, correct? So this 55.9% is nothing but the mass of that XH2O. Is that correct? So you will be having only Na2SO4 on heating it. So the percentage of that XH2O is 55.9%. Can you do that way? See now, I am doing it. Percentage of XH2O is equal to the mass of XH2O divided by the mass of Na2SO4 dot XH2O. Right? We know the percentage of H2O, which is 55.9 divided by 100, which is equal to what is the mass of H2O again? X into 18 divided by 18x plus Na2SO4 mass you have to add there. Is it given in the question? No, it's not given.
142.
So, yeah. So 23
142.
into 2 is 46 and sulfur is 32. This is 64. Yeah, 132 is the right answer. Solve
142.
this.
142.
7. 6 plus 4 is 10. Something. Oh, this is 56. 23 into 2 is
Ma'am, it's
46 only, right?
46, ma'am.
46.
Yes.
And sulfur is 32. Oxygen is 64. So 10, 12. Yeah, 142. I left that one. So 142 is the right answer. So what is X in this case? Can you solve it and tell?
10.
Yeah. Right answer. So what you have here is NaSO4 10H2O, which is option C. You can do it the other way also. This is method A. What's the other method? Can you tell the method B?
Ma'am, 142 by 142 plus 18x is equal to 44.1%.
Good. Very good. So that also you can do. Fine. Yes, that's the other method. So you are going to take the percentage of Na2SO4 present in that. Right. What is the percentage of Na2SO4? Which is 55.9 minus, 100 minus 55.9. So it is coming out to be
44.1.
yes, 44.1. So keeping this also you can do. So which is 44.1 divided by 100, which is equal to 142 divided by 142 plus x into 18. So solve this. Again, you're going to get x as 10 only. Either of the methods, you get the same answer. This is 9th one. Next, 10th one. A welding fuel gas contains carbon and hydrogen only. So they're telling the hydrocarbon contains only carbon and hydrogen. Burning a small sample of it in oxygen gives, see, we are burning it. I don't know what is this X and Y. I'm burning this in oxygen to get 3.38 grams of CO2 plus 0.690 grams of H2O. And no other products are obtained. A volume of 10 liter of this welding gas is found to weigh 11.6 grams. So we know that weight of 11.6 liter of this gas of the hydrocarbon is weighing 11.6 grams. At STP, they have told at STP what is the volume? 22.7 liters. So 22.7 liters is nothing but the molar mass of the hydrocarbon. Find the mass, you get the answer, which is the molar mass. Keeping the molar mass, we will tell the empirical formula and the molecular formula, right? So this X is nothing but X is nothing but 22.7 into 11.6 over, sorry, what was the mass? I have written it wrong, I think.
10 liters.
10 liters. This is correct. This is 10 liters. Yes. So this becomes 22.7 into 11 divided by 10. So this is nothing but 10 and 1 is 10, 16 is remaining, again 1, right? So 22.7 into 1.1 would give you the answer. So approximate, see, in all the options, you just check the answer. 30 and 26 is the molar mass given. 22.7 into 1 is approximately 22.7 and 22.7 into 0.1 is nothing but 1 by 10. So again, you're getting 2.27. Add 2.27, you're going to get 94. 24.9, which is approximately 25. Why the options are this way here is because 22.4 would have been there in the previous assumptions. So therefore, STP would have been taken as 22.4 earlier. According to that, it would match to 26. Right. So here it is 22.4. So the answer what we are getting is nearly 26. So the option C and D has 26, right? So your molecular formula should be multiples. Your molecular formula should be the multiples of
Whole number
empirical
ratio.
formula. Yeah, whole number ratios. So in option C, it is CH and C2H2, whereas in option D, CH2 and C2H. Can option D be possible?
No.
No,
No.
it cannot be possible. It is option
no.
C. CH26 and C2H2. Fine. Yes. 11th one. In an organic compound of molar mass greater than 100, I have told the molar mass of the organic compound is greater than 100, containing only carbon, hydrogen, and nitrogen. It contains carbon, hydrogen, and nitrogen. The percentage of carbon is 6 times the percentage of hydrogen. That's what they're telling. So, percentage of carbon is 6 times the percentage of hydrogen. Let me take the percentage of hydrogen is X. Therefore, percentage of carbon becomes 6X. Right. And one more data they are giving. While the sum of percentage of carbon and hydrogen is 1.5 times the percentage of nitrogen, meaning percentage of carbon plus percentage of hydrogen is equal to 1.5 times the percentage of nitrogen. This is what they are telling, right? So let me take percentage of nitrogen is equal to Y. If I take that as Y, I know that percentage of carbon is 6X, percentage of hydrogen is X, which is equal to 1.5 Y. Okay. This Y I'm going to write it in terms of X. How do we write it? Is 7X divided by 1.5 is Y. So this 1.5 is nothing but 3 by 2. I take 2 to the numerator, which comes out to be 14 by 3x is nothing but y. So can I write y as 14 by 3x? So all we have written it in terms of x. I know that percentage of carbon plus percentage of hydrogen and percentage of nitrogen would be 100. So this is 6x plus x plus, I can directly write this as 7x because we have already written it. 7x plus 14 by 3y should be equal to 100. So can you find x or y in this case? So express it in terms of x. So we will express this in terms of x. So it is already 14.3x, y, right? So 14 by 3x is equal to 100. So what we are getting here is 21 plus 14x is equal to 300. So this is 535x is equal to 300. X is equal to 300 by 35. You're going to get 5 6 is 30, 0, and 5 7s are 60 by 7.
Ma'am,
Let this 60 by 7 be as such. Okay.
ma'am,
Just tell me.
21x
Or 21?
x, ma'am.
Okay, fine. Okay, let it be. Let it be. Okay. So what we'll do is we'll keep as such because our numerical calculations becomes much easier if we keep it this way only. Okay. So if X is
Okay.
60 by 7, what is your, this is hydrogen, right? Hydrogen is 60 by 7. Carbon would be 6 into 60 by 7. Is that correct? Then what will be nitrogen? Nitrogen would be 14 by 3 into 60 by 7. Correct. This is the nitrogen. Take the ratios. Right. Taking the ratios. What we need to find is we need to find the number of moles. Correct. How to find the number of moles? Finding the empirical formula. You have got the percentages. These are the percentages. How to find N? Percentage divided by the atomic mass. So I'm directly doing the atomic mass division. So this is 1 into 12 and this is 14. So this is nothing but 60 by 7 itself is 2. 7, 6 ones are 2s are, 2 ones are 3s are. So this is 30 by 7 is 2. So 14, 14 gets cancelled and 3 ones are 20s are 20 by 7. Multiply everything by 7, you're going to get 60 is to 30 is to 20. Taking the ratios, we have 6 is to 3 is to 2. Is that correct? This is hydrogen is to carbon is to nitrogen. And if the compound is C3H6N2, what would be the mass of this? Molar mass would be 36 plus 6 and 28. It would be 12. Yes, 140. Correct? No, this is coming out to be 70. So they are telling the atomic molar mass is greater than 100, meaning multiples of this would be the molar mass, which is 140. That's the right answer. Fine?
Yes, ma'am.
Yes. Which option is that?
Ma'am, can you
B.
shortly explain, ma'am, once again, shortly?
Yeah. Just a minute. Oh, sorry, it has changed. Just a minute.
Ma'am, 210 is
Yes.
also in the options, ma'am.
But the nearest one you have to tell, right?
Okay, ma'am.
Yeah, the nearest, it is greater than 100. Very nearest to 100 you have to tell. 210 is also right option because 17 to 3 gives you 210, right?
Yes, ma'am.
Yeah. So you have to tell the nearest one, which is greater than 100. Yes. See, I'm explaining it again. What they have told you is the datas are given in such a way that we have to find the percentage first. Correct. So keeping the data, they have told the percentage, first they have told the percentage of carbon is 6 times the percentage of hydrogen. Okay. So if I take the percentage of hydrogen as X, what would be the percentage of carbon? 6 times the percentage of hydrogen, which is 6x, right? So this is 6x. Next, they have told the sum of percentages of carbon and hydrogen is 1.5 times the percentage of nitrogen. So therefore, percentage of carbon plus percentage of hydrogen is 1.5 times the percentage of nitrogen. That's the data which I have written here, right? Now, I know that percentage of carbon is 6x and percentage of hydrogen is x. So 7x is equal to 1.5y. So 7x is 7x divided by 1.5 would be your y. So 1.5 is nothing but 3 by 2. So 3 by 2 is nothing but 2 into 17 divided by 3. That is 14 by 3x. That's nothing but your y. So we have written it in terms of x, which is 14 by 3x. Now we know that percentage of carbon and hydrogen and nitrogen would be equal to 100 because they have told the hydrocarbon contains only these 3 atoms, right? So take these data in the given equation. So substitute that, you're going to get the x, which is nothing but 60 by 7. Now I'm taking the percentage of hydrogen, which is nothing but 60 by 7. Percentage of your carbon is, see, hydrogen percentage is X Carbon percentage is 6x and percentage of nitrogen is 14 by 3x. Keeping this, I have solved this. Right. What did I get is the ratios I'm going to take. Ratios is hydrogen. This is how to find the empirical formula. You have the percentage divided by the atomic mass divided by the least number. All those things you're going to do. Here it is almost simplified because I've taken it in fractions only. So 60 by 7, and this is 6x. So 6 into 60 by 7. This is 14 by 3 into x, which is 14 by 3 into 60 by 7. On solving, you're getting these ratios. So therefore, you have the ratio as 6:3:2, which is C3H6N2. If I find the molar mass of this compound, it was coming out to be 70. But they have told the molar mass or the molecular mass is greater than the 70. So therefore, the nearest one is 140.
Understood,
Fine?
ma'am.
Yeah. Okay. This is 11th one. Coming to the 12th one. Number of gram atoms of carbon and hydrogen in a gaseous hydrocarbon are in the ratio 1:2. Okay. So carbon is to hydrogen is 1:2. Meaning CH2 is your empirical formula. Right. 1 mole of hydrocarbon is twice as heavy as that of N2. Meaning CH2N times is the mass of hydrocarbon. Correct. That is twice the mass of nitrogen, N2, meaning 28, which is 56. Is that correct? The molar mass is 56. Match the compound which is equal to 56. CH2 is not possible. C4H10, C4 is 48 plus 8 is 56. So C4H8 mass is 48 plus 8, which is 56. So your answer is C4H8. So which is option B. Fine. Understood?
Yes, ma'am.
Yeah. 13th one. So 12th one is
Ma'am, 13th one answer is DC2H4.
you got that
Yes, ma'am.
answer?
Option D.
Okay, fine. Can I go to the next one then? Or should I do it? Anybody, if you want me to do the
Yes,
13th
ma'am.
one, should I do or should I skip that question?
Do, ma'am.
Okay,
No,
fine.
ma'am.
Okay, if anyone also wants me to do, I'm doing it. Okay. So 15 cc of hydrocarbon here. Hydrocarbon is CXHY. I don't know what is the hydrocarbon. So 15 cc, meaning 50 ml. Cc is nothing but cm cube. Cm cube is nothing but your ml, 15. Right. Requires 45 cc of oxygen. So oxygen required is 45 ml for complete combustion. On complete combustion, it is going to give you CO2 and H2O, correct? So CO2 given is 30 ml. Keeping this, you have to tell the formula of the gas, right? For that, can I tell the ratio is like this? 1:3:2. Can I tell like this? Andre, 1 mole CXHY if you take and combine with 3 moles of O2, you are getting 2 moles of CO2 and H2O. Correct? Keeping this, I'm writing this equation. Okay? See, for balancing, we have like this. Just a minute. Oh. Just a minute.
Hello.
Is the meeting over?
Go to home and sleep.
ಯಾರಪ್ಪ
Bro, KK student also not watching. Can anyone say? Jagan idea.